So in this tutorial, I'm going to provide some theoretical background or a definition of ROS workspace. So a ROS workspace is a directory used to organize and develop ROS packages. So we learned in lecture 4 about ROS packages. So when we have a robotic applications or we develop a robotic components, then we need to create a package in ROS. So that is everything that we need for the application. For example, say we have a camera, then for the camera, we would need some software. We would need images. We will have dependencies and configurations. All of these relevant files will be stored inside a folder, and that folder we call package. So a ROS workspace is actually a directory or a parent folder under which we will have this package stored. Now, a ROS workspace can have a single package, and it may also have multiple packages. So inside the ROS workspace, or in this under this directory, it's a very conventional way to create another folder that we call the source folder, and in short, we write it as SRC. So within that source folder, we will have all our source packages. So here it demonstrates an example of energy monitor, harvester monitor. So here this on the top we can see this is the workspace. Under this workspace directory or folder, we have this source folder that we have created, and under this source folder we have this folder, which is the energy harvester monitor, and inside that we have multiple files. But we can also see there is another folder which is also named energy harvester monitor, same as its parent folder, which is also energy harvester monitor. So this is a conventional way of structuring the source folder and the workspace overall. This but these two folders have different meaning. The first one, the top on the top level one, this one is called the ROS package folder. So it contains everything needed to describe, build, or install the package. So we know that for the say for a component we need some softwares and stuff. So but we just are not enough with the like codes. For example, in the origin in Python, we're not just sufficient to work with just the codes. We would need further more information or more files to be executed, and all other files will also be stored inside this ROS package. So ROS package, in summary, will have all the necessary files, and one of the necessary files among all of these will be the Python module or package folder, which is this one. This also names the same, but this is one of the many folder that files or folders that the top level ROS package folder will have, and this we call, as I said, Python folder or Python module or package folder. So this basically contains the actual Python source code that we require for our program. Right. So this is what we understand about the source folder under the workspace directory. And then after we have created the source folder, we will have to execute this command, which is called Colcon build, and this builds the packages in the workspace. So here in the second image, we can see that this is the same energy harvester monitor workspace. But under that, we had this source folder, and then as I detailed it, we can see like what's inside this source. So say we have suppressed these so that we don't see the details, and then this is just this. So we have just only this portion from the previous step. But as we execute the Colcon folder, this also creates some other folders in parallel to the source folder. So one is build, one is install, one is log. So all of these are important for a proper functioning of the package. So that's why Colcon build is a fundamental state. So after building, ROS creates additional folders such as build, install, and log. So now that this is ready, another very important step is that we'll have to source the workspace. So ROS2 can find and use the package that we have built. So it's important to understand that even though we have built everything, the ROS doesn't know that there is a package. So we have to introduce ROS that, okay, there is a package and this is your package where you need to act upon. So for that, we'll have to run this command, which is source tilde means it is just tilde just means the home directory, and then energy harvester workspace. And inside that energy harvester workspace, we have this folder, which is the install. And within this install folder, we have a setup file, which is the setup.bash. And this one we have to execute. So as we execute this setup.bash, we will be able to introduce ROS to the package. So it's a very fundamental stage, and we do this under in a good terminal as I open it. So I do all the steps to create the workspace and at the workspace directory, and after that we create the source folder, which will have like the kind of the core stuffs that are required for the package. And then in parallel, we will also create these other folders like build, install, and log, and which are created by just simply executing the colcon build. And eventually we'll have to execute this command source and like show the writing the path towards the setup folder setup file. Will have to basically run the source execution, and that will introduce ROS with the package, and this is good to go for the operation. So this is just a theoretical explanation of how the ROS workspace can be created and what stuff needs to be done. But a more detailed example and how this is actually done in the Ubuntu terminal, we will be exploring in the future lectures. The next few lectures, I'm gonna actually be jumping right into a project where I'm going to be developing an energy harvester monitoring system. So where I will design it. I will have multiple sensor, and one sensor will communicate with another. And for that, we'll definitely need a workspace. And there, I will describe the process in details with examples.